Okay, let's start chapter 4 looking at nomenclature and the introduction to alkanes and the various conformations alkanes can make. Note, alkanes means all the carbon-carbon bonds are single. They're all carbon-carbon single bonds in our alkanes. Okay, and we're going to start by mainly looking at hydrocarbons. Hydrocarbons, of course, are compounds that have only carbon and hydrogen. So an alkane hydrocarbon, all the carbon-carbon bonds are single bonds, and you just have carbon and hydrogen. All right. So note the source of most alkanes and our cycloalkanes comes from petroleum, come from dead dinosaurs and dead plants and stuff like that. The shapes, note that sp3 hybridized, tetrahedral carbons. All the carbons are going to be sp3 hybridized and tetrahedral. Note, we've already looked at isomers, constitutional isomers, um, where you have two molecules with the same formula but different structures. All right, so let's get into the nomenclature. Let's get into the naming of these things. Okay, we're going to use the IUPAC system for this, and the IUPAC system will start with our unbranched alkanes, different table than your book has, or than that number, different book, but it's table 4.1. And here's our summary of our straight-chained alkanes, where CH4 is methane, C2H6 is ethane, propane, butane, pentane, hexane, heptane, octane, nonane or nonane, decane, undecane, dodecane. We won't worry about the tri or tetra or pentadecanes. Don't worry about those too much, but know how to get through dodecane, 12 carbons. All right. So let's see here. Yeah. Something about these alkanes. When you have an alkane, when you have these molecules, they follow a general formula. An alkane, which means all carbon-carbon single bonds, and a hydrocarbon alkane, which means, as we said before, that it's just carbon and hydrogen and are all single bonds. They're going to follow a formula of CnH2n plus 2. CnH2n plus 2. Meaning, if your molecule had, say, 6 carbons, C6, how many hydrogens would that be? Well, 2n plus 2, 2 times 6 is 12, plus 2 is 14. C6H14. And if you look back at your table, you will see that C6H14 is hexane, okay, because of the 6 carbons in there. But that's the formula for these hydrocarbon alkanes. And note, I should be specific, hydrocarbon alkanes that are not cyclic, and we'll get into the cyclic ones later. All the straight chain alkanes. Okay, so we've looked at these unbranched alkanes, straight chain. The branches we're going to call alkyl groups. So we have a CH3 branch is called a methyl group. CH3, CH2 is the ethyl group. CH3, CH2, CH2 is propyl. Note, 1, 2, 3 carbons on this branch, and the branch is connected to the rest of the molecule through this last CH2. If you have this group here, you still have 3 carbons in your branch, so it's still a propyl group because there's 3 carbons. If we look at it, this propyl group is C3H, 1, 2, 3, 4, 5, 6, 7. C3H7, note this is also C3H7, so this is an isomer of propyl, so we call it isopropyl. So If you've got a 3-carbon branch and the branch is connected to your main alkane through the last carbon, it's a propyl. If it's through the middle carbon, it's an isopropyl. Note that we've got butyl groups here. And by the way, the old school for naming this molecule, this group would be not just a butyl, that would be called an N-butyl group, where N stands for normal butyl. You don't see that much anymore. Rarely are you going to see N-butyl, but we still do see it. Recall one of the first labs we used N-butyl chloride and N-butyl bromide, which is just old school way of saying you had a butyl group and a bromine at the end. N-butyl bromide. You do not see that too much anymore, the N for normal, but occasionally you do. If you see the low N, the lowercase n, realize that just means a straight chain group. So N-propyl would be this. Some people would call this N-propyl, and this would still be isopropyl. All right, so we got a butyl, but there's various isomers of butyl. We can have this isobutyl group down here. You can have a secondary butyl here. You can have a tert butyl group here. All 4 of these butyl groups are isomers of each other. They're all butyls, meaning they all have 4 carbons there. They all have the same formula. It's just here, if the 4-carbon chain is attached through the end carbon, it's just a normal butyl, or we just call it butyl. If it's at a CH2 and the next carbon over has 2 CH3s, it's isobutyl. If it's attached to the normal or regular alkane at a CH that has a CH3 on it and a CH2, well, that's sec-butyl. Just a carbon with no hydrogens on it gives us the tert butyl. And old school, that's the problem with naming these compounds. There's a lot of old school. Tert butyl used to just be called T-butyl for short. So if you hear me say T-butyl, because when I learned it a long time ago when we rode dinosaurs to school, and we called it T-butyl back then. It's today everyone is tert. Let's go with the tert. Okay, so it's tert butyl. Here is pentyl. You actually do have isopentyl and other things. You also have this crazy group neopentyl also. All right. So let's look at now how we're going to name their molecules, and we're going to name it based off of the unbranched alkanes and after the alkyl branches. Now, here are the rules. We'll go through them quickly, but once we start using the rules to figure out the names, they'll just make a whole lot more sense. Rule. First, find the longest carbon-carbon continuous chain. A carbon bond to another carbon bond to carbon. If there's an oxygen in that chain, well, then that chain ends at the oxygen. The longest continuous carbon-carbon chain, how many carbons are in that longest chain? That gives us the name of the parent name of the molecule. You start numbering the carbons in this longest chain, beginning at the end nearest a substituent, nearest a branch. So, or another way of saying it, the lowest you're going to give that branch the lowest number at the point of difference. So wherever that branch is, that carbon containing that branch will get the lowest number possible, always starting though numbering from the end. You're going to designate the location of the branch, the number of the carbon that the branch is on, the carbon number that the branch is on. List all substituents alphabetically. You're going to use di, tri, tetra if there are identical substituents. And if you happen to find you have 2 equal length chains, it's rare, but you can find it. You choose the one with the larger number of branches. Okay, you got those rules memorized yet? Of course you don't. But let's go through them. Let's go through naming our molecules. Ooh, it's not even on the page. There's the rules right there. Let's go through. They're in your book also, so don't worry about that. Your book goes through it a little bit more long form. I don't even see the rules just written down in your book. But yeah, they take many pages to go through that. There's the basic rules. Okay, so let's name some molecules. All right. This top one here, if you see this, I like line structures. Everyone likes line structures. What would be the name of this molecule? Well, let's count the number of carbons. We can see we've got 1, 2, 3, 4, 5, 6, 7 carbons in this longest chain here. You find the longest continuous carbon-carbon chain. We see that, oh, we have to start numbering it from the end closest to the branch. If I made this carbon 1, 1, 2, 3, 4, 5, 6, then this group here would be on carbon 6. If I made this carbon number 1, then this is on carbon number 2. You always number it so that the first branch has the lowest carbon number. So we're going to number this one 1, 2, 3, 4, and such to give this branch the lowest carbon number 2. Note that this is a CH3 sticking up from this number 2, which is a methyl group. And so now that we've got all the carbons labeled in the longest chain, we know what that branch is. There's only one branch. It's at carbon 2. We're going to call this 2-methylheptane. No spaces. 2-methylheptane. Just a dash between the 2 and the methyl. And that tells us our molecule, 2-methylheptane. Let's look at this molecule down here. I think we can tell that this is the longest branch right here. Excuse me, our longest chain. But do we start numbering from this end or this end? Because if we number from this end, this will have, this first branch would be on carbon 2, 1, 2. Here it'd also be on carbon 2, 1, 2. But note, we have another branch here. So this would have the first branch at 2, the second branch at 3. If we started number 1 here, this would have the first branch at 2, 3, 4, 5, the second branch at 5. 3 is smaller than 5. So we're going to number from this end, our first point of difference. 1, 2, 3, 4, 5, 6, 7. Note, we've got 3 branches. We've got this one here, and this one here. All 3 of them are methyl groups. Since there are 3 methyl groups, we use a prefix tri. So we give the name or the number for each carbon. 2, 3, and 6. 2, 3, 6. Trimethylheptane. Can you see where we get 2, 3, 6 trimethylheptane from? Heptane, because there's 7 carbons in the longest chain, the parent molecule. Trimethyl, because each branch is a methyl group. 2, 3, 6, because we have to tell which carbon of our longest chain that the methyl groups are on. 2, 3, 6 trimethylheptane. Look at this one. Longest chain. Note, I made the longest chain 1, 2, 3, 4, 5, 6. But what about 1, 2, 3, 4, 5, 6? You'll find out it's the same no matter which way you do it. Note, carbon number 2 has a methyl on it. Carbon number 4 has a CH2, CH3. That's an ethyl group. So we have a 2-methyl and a 4-ethyl. Which comes first? Recall from our rules, you name it alphabetically. Name the branches alphabetically. Ethyl comes before methyl because E comes before M. So this would be 4-ethyl 2-methyl hexane. 4-ethyl 2-methyl hexane. All right. And yes, number 2 comes before number 4, but when you name it, it's alphabetically. So it's 4-ethyl because E comes before M. Which brings us to a weird type of situation. Let's go back to our branches on that previous page. All right. When we were looking at our branches and how we named our branches, the question is, what letter does each branch start with? And you're going to find out it's not that easy. Well, methyl starts with M. Ethyl starts with E. Propyl starts with P. Isopropyl starts with I. Butyl starts with B. Isobutyl starts with I. Sec-butyl starts with B. Tert-butyl starts with B. Question. Why do the isos start with I, but the sec and the tert start with B? Can you see? The answer is this hyphen. Butyl is the name of the group. Sec just tells us its conformation. But here, isobutyl is the name of the group. There's no hyphen here, therefore this starts with I. There's hyphens here, so this starts with B. Note, so alphabetically, you would put butyl, sec-butyl, before ethyl, because B before E, sec-butyl comes before ethyl. If your molecule had a sec-butyl and a tert-butyl in there, then sec-butyl would come before tert-butyl because of the S and the T. But they are both would come before anything else because they're both butyls. Okay. Let's continue on with naming some molecules. Let's name these guys. All right. So, this one here, how would you name that? So, give you time. Name it, pause, unpause. Did you get 3-ethyl, 3-methyl? What is that? I can't even read that writing. What is that? That is heptane. Nope. Excuse me. 1, 2, 3, 4, 5, 6. Hexane. 3-ethyl, 3-methyl hexane. That's what it is. All right. This next one. What do you get for this one? Did you get 2,2,4 trimethylpentane? Note, it's 3 methyl groups, and this carbon is going to be carbon 2 because we've got 2 branches on it. This carbon is, you wouldn't want this carbon to be carbon 2 because it's got 1 branch on it. So you don't want to name it 1, 2, 3, 4, 5 this way. You want to do it 1, 2, 3, 4, 5 this way because 2 branches there. This one is already a little helpful for you. If you look at our numbering here, one might say, wait a minute, 1, 2, 3, 4, 5, 6, 7. I understand why we would start numbering down here because that puts a branch on carbon 2. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Which way do we go? Do we go this way or this way? Both longest chains have 7 carbons in them. Well, the answer is, if we go this way, we see we have 1 branch, 2 branch, 3 branches. So if we just go number it here, 5, 6, 7, we'll have 3 branches. 1, 2, 3. But if we number the way the number is written here, the numbers are written here, we get 1, 2, 3, 4 branches. Recall, if you have 2 of the same length chains, the one with more branches is the correct one. So this 1, 2, 3, 4, 5, 6, 7 gives us 4 different branches. So how would we name this? Well, methyl at 2, methyl at 3, 1, 2, 3, propyl at 4, methyl at 5. Did you get 2, 3, 5 trimethyl 4-propyl heptane? All right. So, name that. What is that beast? That's a beauty, eh? Oh, and by the way, the 2 things that you do need to be able to do, one is to name the compound, given the structure of the compound, be able to name it. The other is, given the name of the compound, be able to draw the molecule. It's actually easier to do the second thing. It's actually easier, given the name of the compound, to draw it. Because if I said, okay, 2,3,5 trimethyl 4-propyl heptane, and I wanted to draw that, start at the end. Heptane. 1, 2, 3, 4, 5, 6, 7. Okay. 4-propyl. 1, 2, 3, 4. Here's carbon 4. Propyl is 3 carbons. 1, 2, 3. 2, 3, 5 trimethyl. 2, 3, 4, 5 trimethyl. So I strongly recommend when when given the name and drawing the structure of the compound, start at the right and work your way to the left. Write down the parent and then keep going backwards to put on the groups. Note that's a lot easier than given the structure of the molecule, the line structure, trying to name it. It's easier to get the structure from the name than vice versa, usually. All right. So do that. Name this molecule, and then from your name, draw what the molecule can be and see if you're right. Okay. Well, that's enough for naming alkanes. Let's start putting groups on there. Let's start naming alkyl halides and other things.